Hello, welcome back to our channel. Today we are going to discuss about in our crash program, day 13 program. Our chapter name is the electric charges and fields. This is the basics of complete electricity. If you are perfect in that, automatically you will get more grip on electric potential and capacitance, current, electricity, moving charges and magnetism, alternating current. Almost wherever that electric topic is there, you can able to get more clarity on it. Anyway, come to our point. In our day 13 program, we are going to discuss about what is the electric charges and fields. Just we are going through the revision of all formulas. In this, first we are starting with what is the charge. Okay, it is the property of the matter. It can able to produce the electric field. As usual, it can able to produce the magnetic field. At the same time, charge is affected by both electric and magnetic fields. That is called the charge. Charge is mostly represented by Q. That unit is the coulombs and the dimensional formula is IT. How you can remember this one? IT, information technology. Current into time is nothing but IT. Like that you should remember that. So here charge is the property of the matter. The unit for charge is that is the coulombs and the dimensional formula is IT, information technology. It's not correct meaning, just for remembering purpose I am saying that one. Then you know that in this chapter, entire chapter we are focusing on charges at rest condition. In other chapters we are going through the charges at moving condition. So what is the difference? Always you should remember that when charges at rest condition can able to produce only electric field. When the charges are in moving condition, they can able to produce both electric and magnetic fields. That is the difference between them. Actually, this chapter name was electrostatics, charges at rest condition. Charges at rest condition can able to produce only electric field. Then come to our point. There are two types of charges. What are those? One is the positive charge, another one is the negative charge. How to define the positive charge? If anybody is losing the electrons, okay, that is getting the positive charge. Same if the electrons are absorbed by that one. Sorry, actually, if the body is losing the electrons, lack of electrons is producing the positive charge. If the body is gaining the electrons, excess electrons is giving the negative charge. So we can't say that permanently it is positive charge, and we can't say it is permanently negative charge. When the body is losing the electrons, you can say that is positively charged. If the body is gaining the electrons, you can say that is negatively charged body. So how many types of charges are there? There are two types of charges. One is the positive charge, another one is the negative charge. Then how to calculate the charge of the body? That is from the quantization of the charge. And before that, we are going to discuss how many methods are there to electrify the bodies. There are three methods to electrify the bodies. One is by friction, another one is by conduction, then third one is by induction. So how many methods are there to electrify the bodies? First one is the friction. When you rub two bodies, suppose one glass rod is there, you feel this is the glass rod. When we are taking one silk cloth and rub that one, then silk is gaining the electrons, this rod is losing the electrons. Now immediately you can say that initially no charge, but whenever it is losing, it is gaining the electrons, losing the electrons, positively charged body. Whenever silk cloth is gaining the electrons, you can say it is negatively charged body. So this is one of the method to electrify the bodies. Then what is the second one? Our second one is the by conduction. Here we should connect two bodies. Suppose one is like it is having the 10 coulombs. When you are connecting to the neutral body, means charge is how much? 0. So the current here, charge is flowing from high potential to low potential, or wherever the charge is there, unless it is balancing, it is coming to other body. This is called by conduction. So this type of method is called by conduction. So whenever you are taking two bodies, first body 5 coulombs and second body is the 20 coulombs. Whenever you bring together and you separate it, then what is the individual charges? We can take the average of the two charges, Q1 plus Q2 by 2. Suppose first one is the 10 coulombs and second one is the 5 coulombs, and you bring together and then you separate it. Now what is the new charges on both bodies? 15 plus 5 by 2. So now each one is having how much charge? 10 coulombs is the charge. So this is called the conduction. Then induction. In friction, what we are getting? Unlike charges. In conduction, we are getting the like charges. In induction, there is no contact between the bodies, even though you can able to produce the electric charge. That method is called by induction. In induction, what happens? Look here, we are taking, this is positively charged body, placing nearer to the neutral body. Neutral body means number of positive charges equals to number of negative charges. So then what happens? All negative charges are coming like this, and these are arranging like this. Then this side we are giving to earth connection. You know that then electrons are moving to here, it is balanced. This side it becomes to neutral, and finally we are getting as usual positive charge, and here we are getting the negative charge. So by induction we are getting, if we are using the positive charge, you will get the negative charge. If you are using the negative charge, you will get the positive charge. So this is called by induction. So in conduction, average we are taking. In induction, we are getting that unlike charges. Suppose we are filling here one dielectric, we are getting Q dash equals to Q into 1 minus 1 by K. Here K is the dielectric constant. Here we are placing with glass slab or any wood like that. Then we are getting that Q dash equals to Q into 1 minus 1 by K. K is the dielectric constant. So there are three methods are over to electrify the bodies. Then come to our next topic is very important, that is called the quantization of charge. What is the quantization of this charge? Suppose one object is there. What is the charge of the body? Then they are bringing another one. What is the charge of this body? How to calculate? Based on the number of electrons, we can say yes, this is having this much charge, that is having that much charge. Otherwise, one more definition is that the integral multiple of charge of electron is called the quantization of the charge. Look here, what is the quantization of charge? Quantization of charge, we are taking, the formula is Q equals to plus or minus N. N is the number of integer, number of electrons, N equals to 1, 2, 3 like that you are taking, and E is the charge of the electron. You know that 1.6 into 10 to the power of minus 19 coulombs. You should remember that. No one will give in exam. You should remember that what is the charge of the electron? 1.6 into 10 to the power of minus 19 coulombs. The formula for to find the charge, that is called the quantization of the charge. You can say that it is an integral multiple of charge of electron, or one more definition, the minimum electrons transferred from one body to the another body, then it is giving the charge of that body. So Q equals to plus or minus NV. And we do one problem also. Look here, if N equals to 100, if it is losing, we are getting positive charge. If it is gaining, you will get the negative charge. Then what is the charge of this body? 100 into 1.6 into 10 to the power of minus 19. So it should be right 1.6 into 10 to the power of minus 17 coulombs. Like that we should calculate. Not only this one more problem we are doing here. Look, if Q equals to 1 coulomb, find number of electrons, N value. So N equals to Q by E. Q is 1. 1 by 1.6 into 10 to the power of minus 19. So N equals to 1 by 1.6 is a 0.625 into 10 to the power of 19. So in 1 coulomb charge, look here how many number of electrons are there? 0.625 into 10 to the power of 19 number of electrons are there. So this is the use of this quantization of the charge. We should calculate the charge of the body. Then come to charge is conserved. You know that law of conservation of energy. Energy can neither be created nor be destroyed, but it can be transferred from one body to the another body. Like that here, we can't create charge and we can't destroy charge. Because of the transferring of charge, we can say that it is negatively charged or positively charged. Finally, what do you say? Charge is conserved. This is called the law of conservation of charge. Then come to Coulomb's law. From the Coulomb's law, how much force is acting between the charges? We can say that, you know that like charges are repel and unlike charges are attract. Even repulsion or attraction, we should consider both are some force is acting between the charges. How to calculate that force? For this, he has taken two charges. One is the Q1, another one is the Q2. Both are separated by a distance of r. From the Coulomb's law, he said, how much force is acting? This force is directly proportional to product of magnitude of these two charges and inversely proportional to distance square. And inversely proportional to distance square. When you should combine these two, what you are getting? F is directly proportional to Q1 Q2 by R square. Instead of proportionality, you are getting for medium, for free space or vacuum, F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. For medium, you can take it 1 by 4 pi epsilon Q1 Q2 by R square. This value, this epsilon naught is the permittivity of the free space. You should remember these values also. It is very important for calculations. Epsilon naught equals to 8.85 into 10 to the power of minus 12 Coulomb Newton meter square. Then 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. So this is about the force. If any medium we are taking, we can't say it depends on that medium, we are taking that epsilon value. And relative permittivity. What is the formula for relative permittivity? This is represented by epsilon r or k also. Just now I said this k is nothing but relative permeability or dielectric constant also, you can say that. That formula is, generally you can take it, epsilon equals to epsilon naught into epsilon r. Epsilon r is the permittivity of medium by permittivity of free space. That is called the relative permeability. So k equals to epsilon r equals to, the formula is epsilon by epsilon naught. Okay, this is belongs to Coulomb's law. One problem we are doing, see, if Q1 equals to Q2 equals to 2 coulombs, R equals to 2 meters. Then how much force is acting these two? This value is 9 into 10 to the power of 9. Both are same. 2 square means 4. R square is the 4. So how much force is acting? 9 into 10 to the power of 9. Force means the unit is how much? Newtons. So F equals to 9 into 10 to the power of 9 newtons is acting between the two charges. See, now we are focusing on the applications of that Coulomb's law. What are the applications? Already you know this Coulomb's law. See, if the charges are different and distance is same, what we are getting? F1 by F2 equals to Q1 by Q2 by Q1 dash by Q2 dash. Here what we are taking? Actually this is the 4, 2 and next one we are taking 3 coulombs and 6 coulombs. 3 coulombs and 6 coulombs. And here also 2 meters, here also 2 meters, same medium. Here then how to find out the ratio of the forces? F1 by F2 equals to 8 by 18, you are getting that 4 by 9. Then second case, if charges are constant, so here 4 and 2 and here also we are taking 4 coulombs and 2 coulombs and we are taking the distance is different. First one is the 8 meters we are taking, then second one is the 2 meters. Then how to find out the ratio of the forces? F1 by F2 equals to, both are inversely proportional, means R2 by R1 whole square. After simplification, the answer is 1 by 16. Not only this one, these forces are affected by the medium also. If forces and charges are constant, then what is the relation between epsilon and this R square? Epsilon R square equals to constant. So epsilon is inversely proportional to R square. So we can write it epsilon 1 by epsilon 2 equals to R2 by R1 whole square. So suppose here R1 is 4 meters, then R2 is 6 meters. Then epsilon 1 by epsilon 2 is how much? You can take it reverse of this one, 6 by 4 whole square, 3 by 2, answer is 9 by 4. Like that, any situation we can handle with the help of the Coulomb's law. So these are the applications of the Coulomb's law. And not only this one, suppose where you will get the neutral force. Neutral force. This is very important. It is not only for force, it is coming in magnetism, it is coming in intensity of electric field, and many topics you are getting this concept. Look here, we are taking two charges, one is the Q1, another one is the Q2. Both are separated by a distance r. Both are separated by a distance r. Now in between that, we have to place one more charge. then the resultant force equals to 0. Look here. We are taking how many charges? 2 charges only. Both are separated by how much? The distance is r. Now we are placing one charge, adjusting between them. At that time the resultant is force is 0. At what distance we are getting the neutral point? Actually direct formula is there. That is x equals to r by under root q2 by q1 plus r minus 1. q2 by q1 plus r minus 1. So q2 is the second charge and q1 is the first charge. R is the distance between these two charges. So we can go through the, suppose plus is for like charges and minus is for unlike charges. This is for unlike charges. One problem also we are doing here. If r equals to 6 centimeters, q2 equals to 9 coulombs and q1 equals to 1 coulomb. Then where you should get the null point means r value how much? 6 by q2 by q1 under root 9 is the 3. Through 3 both are like charges, positive, positive. So like charges you can take plus 1. So our answer is 6 by 4. 4 1 ja 4, 5. So 1.5 centimeters. Actual distance is the 6 centimeters. Because of the placing of one charge, then what happens? Where you should get the null point? 1.5 centimeters from the smallest charge, from the q1. And where you will get the null point from the second one means you have to do 6 minus 1.5, 4.5 centimeters. So depends on the question. Don't stick only one formula. Suppose I am pulling this wall means okay, that force with the rope, and there are different ways to apply the force. So don't stick only for one formula. Based on the situation, you have to deal that problem. So this is the application of this one. Where is the null point means immediately you have to remember that. And one more problem we are taking. Q1 is the 16 coulombs. Q2 is the minus 1 coulomb. The distance r equals to 4 centimeters. Here how to find out the null point? X equals to 4 by q2 by q1. This is the 4, this is 1 and this is 16 you are taking. Under root 16 is how much? 4 by 1 means 1 only. But here I am taking minus 1. Why? Both are unlike charges. This is 1 coulomb and this is minus 16 coulomb means answer is 4 by 3, 1.33 centimeters. Like that we should find out the where you will get the neutral point. So this is belongs to the Coulomb's law. Now till now we discussed about two sets of the charges. Some force is acting. If it is unlike attractive force, if it is like repulsive force, and you know that how to calculate the forces and how to find out the ratio of the forces when two sets of the charges, when two sets of the forces, when two sets of the distances, when two different types of the mediums also we can able to find out. Now we are focusing on what is the principle of superposition. Suppose n number of charges are there, how to find out the force? Look here carefully. With the help of the principle of superposition, we can find out the resultant force. You are taking n number of charges here and we are using the principle of superposition. It is coming many chapters, waves, it is coming electric charges and fields, wave optics, ray optics, not ray optics, wave optics it is coming. Look here. Principle of superposition. Principle of superposition. See, one charge is there, Q. Here one Q1. The distance is R1. Q2. The distance is R2. Like that n number of charges. Here the distance is Rn. Here what is the resultant force? Algebraic sum of the individual forces F1, F2 plus and so on Fn. Instead of, in this case, all cases 1 by 4 pi epsilon naught is common. Instead of F1, Q1 by R1 square plus Q2 by R2 square plus so on Qn by Rn square. So we should add the individual forces. You can get the resultant of all these forces. And what are the limitations of Coulomb's law? Some limitations are there. When the charges are moving, we can't apply this Coulomb's law with the help of that velocity, not velocity of light. If the charges at rest condition only, Coulomb's law is applicable. So this is about the principle of superposition. Based on that, few more applications. Look here, we are taking one triangle. This charge is Q, this charge is Q, and this is the minus Q. All three sides, how much distance is there? R. Resultant force, find resultant force on minus Q. How to find out? See, always the force is acting away from the positive charge and towards the negative charge, or you can say the line joining of the two charges. See, this is A, B, C. Between A and C, how the force is acting? F1. Between B and C, how the force is acting? F2. It is equilateral triangle, means immediately what we are taking here, the angle is how much? 60 degrees. Then resultant of these two forces, how much? Here F1 equals to F2 equals to, both are same because the distance is same, charges are same, Q square by R square. But the angle between F1 and F2 is how much? 60 degrees. From the parallelogram law of addition of vectors, you can say that resultant force is F root 3. So instead of F, we are taking either F1 or F2, 1 by 4 pi epsilon naught Q square by R square into root 3. If they are giving values, Q equals to 4 coulombs and R equals to 2 meters, then you know that epsilon naught value. So here resultant force is how much? 9 into 10 to the power of 9. Q square is how much? 16 by R square is the 4 into root 3. After simplification, you are getting resultant force is 36 root 3 into 10 to the power of 9 newtons. Like that we should calculate. Not only this one, suppose we are taking 3 equal charges. This is the Q and this is the Q, this is the Q. We are placing at the vertices of equilateral triangle. Vertices of equilateral triangle. So what is the resultant force on any charge? Because all are same only, no? That too the distance is same R. Suppose we want to find it here. In this case, how to find out the resultant force? See, the line joining of these two charges. So one force is acting like this. One force is acting like this. Another force is, this is the one force we are taking, F1. And another force is acting, it makes an angle of how much? 120 degrees. This is the F1 and this is the F2. Suppose we want to find out here. See, one force is acting like this, another force is acting like this, and here how much angle is there? 120 degrees. If angle is 120 degrees, here F1 equals to F2 and theta is 120 degrees. What is the resultant force? Resultant force is either F1 or F2. We are getting 1 by 4 pi epsilon naught Q by R square. So here where you should stress what is the difference between these two applications. In this case, two are the positive charges, one is the negative charge, you will get like this. Here all three are the positive charges, that's why 120 degrees angle, same force you are getting whatever that it is. Like that same thing you should apply for one square also. How to apply I am showing here. Look. See, one square we are taking. Charges Q, Q, Q. Here minus Q. The distance is R, R, R. A, B, C, D. Find the resultant force at D. How to find out? See, same thing. Here one force is acting F1 and here another force is acting F2. Here F1 is equals to F2 but theta is how much? 90 degrees. So resultant force I am taking F3. F3 is acting like this. So F3 is how much? Root F1 square plus F2 square, both are same, means what we are getting? F1 root. F1 is how much? 1 by 4 pi epsilon naught Q square by R square into root 2. From the parallelogram law of addition of vectors, we know this. Okay, then come to one more charge is there. Here, what is the distance? When we are applying the Pythagoras theorem, under root R square plus R square is how much? R root 2. So this I am taking F4 and this is the F3. Here F3 is parallel to F4. So F4 is how much? 1 by 4 pi epsilon naught q square by, but the distance is r root 2 whole square means r square into 2. So but here F3 is parallel to F4. So final resultant force is how much? Just we can add F3 and F4. What is the common in both the cases? 1 by 4 pi epsilon naught q square by r square is the common. So here you are getting root 2 plus 1 by 2. One problem also we are doing, if q equals to 4 coulombs, then r equals to 3 meters. Then how to find out the resultant force in this case? 9 into 10 to the power of 9 into, here q square means you are getting 16 by, this is the 9 into root 2 plus 1 by 2. If you want to do more simplification, instead of root 2 we should take it 1.414. Instead of 1 by 2 we are taking the 0.5. Then we can find out the resultant force. And one more application I want to share with you. That application, look here. See, we are taking one equilateral triangle. This is the charge Q, 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 and here we are placing one more charge Q. Always you remember that for the equilateral triangle, just this is R, this is R, this is R, this is how much? R by root 3. R by root 3. Suppose it is minus charge. How to find out the resultant force? See, one force is acting like this, F1, due to this one. Another force is acting like this, F2. Here how much angle is there? 60 degrees. So F1 equals to, F2 equals to 1 by 4 pi epsilon naught. But the distance you see, this is R by root 3. So we can write it Q square by R by root 3 whole square. Resultant of these two forces, how much? You can take it 60, angle equals to 60 degrees. So F root 3. So this value is 1 by 4 pi epsilon naught. When it will reverse, 3q square by r square into root 3. This one. But one more is there. This is also one more chart. It is acting like this. It is acting like this. So resultant of these two forces are acting like this, and resultant is this one. And one more charge is there. That is charge. This is acting downwards. Both are anti-parallel to each other. So we can subtract in this case. Like that, whatever the method we can use with the help of that parallelogram law of addition of vectors, we can find out the resultant force when we are using n number of charges, 4 charges, 3 charges, in the case of square, in the case of rectangle. But you look at what are the signs of that one, is it positive or negative. I hope you understood part 1 of that electric charges and fields, and I think I made 2 more parts belongs to intensity and one more is the Gauss's law. So we are expecting 2 questions sometimes, and we are expecting 1 question from this. So those who are subscribing my channel Rishit Physics classes, their playlist is there. In that playlist, those who want that crash course, you have to go through the crash course day wise. Those who want any first year LAQs, VSAQs, you can use that one. Any simple definitions you want, you can go through that. And here few practicals, experiments, practicals also it's there. Some experiments I have done, you can follow that one. So please subscribe my channel and share it, and if you like, you should like, and you can share the knowledge also. Thank you everyone.